Hello guys, welcome to my YouTube channel. Today we will be just doing some introduction to differentiation and integration. So basically I want to teach you how to make use of the formula sheet. The N4 formula sheet it's very short. It's like 1 page. When you get to N5 and N6 you get like 5 pages, 6 pages of formula sheet. Yeah, so in N4 it's not that hectic. It only gets hectic as levels go up. Yeah, so yeah, let's get to it. So okay, I think it's best we start here. But first, guys, don't forget to subscribe to my channel. So you can just go there, search me. My full names. Then you will see me there. You subscribe. You can go to my channel. And the easy way to browse, if you just click on playlists, then you can check your subject. In this case we are in N4. You can see I already have some other videos. Alright, let's get back to business. Okay, this is from the July 2021. I just want us in this video only to focus on the formula sheet. Then the next video I will do video on differentiation techniques, then later maybe other video on integration. Okay, so let's start from the table. I think that's the easy way to go. Let me see if I can use a different color. Okay, so first on the left side of the table here we have product rule. So how do you see a product? Is when you have two different equations multiplying each other. So in N4 it's usually easy. They tell you that this is a product rule, then you know you have to follow this rule. So if I have a function of u times a function of v, then I have to follow these rules. We will do that when we do the product rule and quotient rule. I'll do a separate video for that. Then we have quotient rule. This is when you have two functions dividing each other, two different functions. When I say different, it's, for example, if I have sine x over ex, that's two different functions, right? There's no way you can combine them. Like if I had sine x over cos x, I can just make that a tan, right? So yeah, this is what I'm talking about. Even product rule, let's say I have sine x times e exponent x. It's two different functions. That's product. But again, they will tell you that differentiate this using a product rule or a quotient rule. Now let's get to this table. We have y on the left side, then we have dy dx. Dy dx is the derivative, right? So from y to dy dx we have, it's called differentiation. When you integrate, it's the opposite. For example, check sine. The differentiation of sine will be cos x, but the integration of cos will be positive sine x, because integration is the opposite of differentiation. It's like a reversible equation. So now if the differentiation of cos is negative sine here, the differentiation of cos is negative sine, what will be the integral of sine? It will be negative cos, because that negative should still be there. You need the negative because we have negative in the mix, right? For example, the differentiation of cot, it's negative cos x squared. So the integral of cos x squared will be negative cot squared. Then the differentiation of sec, it's sec tan. The integral of sec tan will be the integral of sec tan will be sec, because it's the opposite. You just go from sec tan. So every time you work with integral, you check from the dy dx, you go back to y. It's like you are reversing the equation. So now some integrals which are not in the formula sheet, like what is the integral of cot? Okay, not cot. Tan. What is the integral of tan? Because we can see the differentiation of tan is sec squared. But what is the integral of tan? If you check under dy dx, we don't have any tan, right? Then you can get them here. This is extras you have there. What is the integral of sec under dy dx? There's no sec. You can check it there. It's ln sec plus tan. What is the integral of cos? It's positive sine. We have it from the table. We just check for cos on the dy dx. You can see it gives me positive sine. The integral of sine, you check for sine. It's negative, so it will be negative cos. You see, like that. Now these other integrals, these three here, they are from the table. I will show you how. Let's first focus on the first rule. The first rule, the formula sheet have been like this for ages. I don't know why they don't fix it today. So this is basically a x exponent n. It's not a n exponent n. It's a x exponent n. So this is when you have any algebra function, like if I have a 2x exponent 4, your a is 2, your n is 4. Do you see? And what's the answer for that? If this is y, what will be my dy dx? What does it say on the answer? It says that exponent multiplies the a, so the 4 and the 2 will multiply, then the exponent will be subtracted by 1, n minus 1, which I'll be left with 3, 8x cubed, right? Now that's differentiation. Can we do integral of that, which is this one exactly, this one here? If I have integral, let me write it here. If I have integral of 2x4 dx, what does the answer say? It says I will still have 2x exponent what, n plus 1, which will give me 4 plus 1, which is 5, over that n plus 1, which is the direct opposite. What did we do in differentiation? We first multiplied the a, then subtracted the exponent. This is what we did in differentiation. Now in integration, we are going to do the exact opposite. The last thing we did in integration was was subtract. So in integration, we're going to start with add, then I think the arrow is confusing me. We're going to start with add, then divide, because in differentiation we multiplied, then subtracted. Integration, add, divide. So that's why you can see your answer from the 2x exponent 4 in integration, it didn't change. It's still 2, then I'm adding the exponent and dividing. But in differentiation, you first start by multiplying the exponent with a, then you subtract the exponent. You see, it's the opposite. Okay, that's one rule. Number 2 is the exponent. You have kax. Notice something on the answer for differentiation. You still have kax, then they added ln a. Check the differentiation. If I have kax, what do I have on the answer? I still have kax, but instead of multiplying by ln a like they did in differentiation, they divided by ln a. So let me show you how that works. So let's say I have 2 exponent x as my y. If I'm asked to differentiate that, the rule says first thing you write it as it is, then ln a. What is a? A is the number that has an exponent, which is 2. The reason I'm saying that is because I've seen many students get confused. Let's say I have 3 times 2 exponent x. When I differentiate, first thing first, if it's an exponent, copy it exactly as it is. Then multiply by ln what? Ln 2, because 2 is the one that has the exponent. It's your base, it's your a. Because if you check the formula sheet there, a, it says ka exponent x. Then the answer, it still has ka exponent x ln a. They don't say ln ka. Do you see? So now let's do integration of the 2. Now I have integral of 2 exponent x. First thing, write it as it is. Now divide by ln of the base of 2, which is the base. Then don't forget, with integration you always add c, it's constant. The same thing, if I have 2 exponent x dx, first thing I do is write it as it is. Then divide by ln of a. You see? Just like that. But now there is one thing they don't usually show on the formula sheet, especially in N form. It's you always have to multiply by the differentiation of your exponent. So the reason they are not showing it here is because all the examples here, they are showing x as only 1x, sine 1x, cos 1x, tan 1x, k exponent a 1, ka exponent 1x. So the differentiation of x only is 1. We know that, right? I'm sure we agree. If y is x, what is the differentiation of x? It's only 1, because this is exponent 1. It will be 1 exponent 1 minus 1 x exponent 0, which is 1. I'm sure we know that. That's some basic rule you should know. If you from metric, we know that, right? So, okay, so let's leave this one out. So I was saying, they do not show you that one extra step is you always multiply by the differentiation of the exponent. For example, 2 exponent x ln 2. At the end, you multiply by 1, which is the differentiation of x everywhere. But you don't show that one. There's no need, right? But there's a question that you really need to show that one. Let's say I have y equals to 2 exponent 3x. What will be my dy dx? First thing, copy it as it is, ln 2. Last thing, differentiation of 3x is 3. That's very important. Never leave that one out. The same thing with integral. If I have integral of 2 exponent 3x dx, my answer will be 2 exponent 3x. Then do the opposite of what you did in differentiation. So I'm going to divide by ln 2 times 3. You see? And that 2 and 3, they cannot be multiplied together because they are not in a bracket. The ln 2 belongs to the ln. You see? Just like that. I hope that rule we understand. Can we get to another rule? Now we have ln k ln x. K ln x. The answer is k over x. K over x. So this is because the differentiation of ln is 1 over x. So if there's a k there, it will be the constant times 1 over x, right? So what I'm saying is, let's go here. If I have 2 ln x, my answer will be 2 over x, like that. I hope that's clear. If I have what can I say? I think some are tricky, especially let's see. Yeah, I don't think. Okay, this is N4. Let me not try to confuse them. I think ln will end there. For example, let's say you have 2 ln x cubed. Not x cubed, x squared. Not x squared. Let's say the 3 is here. We know this is just like in making a huge mistake. The 3 is there, it's exactly there. This is just like in log. Remember, if I have log 2, let me say 3, I can change that to log 3, 2. You see, the exponent can from in front of log can the number from in front of log can go to the exponent, and vice versa. It can go back to in front of log like this. So if you have a number like this, always take it to the front. So 2 times 3 will give me 6. Then now I only simplify. Now I can integrate. This will be, I can differentiate, which is 6 over x, right? Yeah, I think with log, it's not that hectic. So now with log, we can see from here, if I differentiate a ln or a log, I'm getting k over x. So which means if I have to take it back to integral, it must start as a function, then go back to integral. So which means any number over x, if they say integrate 10 over x dx, my answer will be 10 ln x, because we know 1 over x it's ln. 10 is just a constant. Then don't forget the plus c, right? This only gets tricky. I've seen with students, this only gets tricky if they give you an exponent. The only time this will be a ln, it's if the exponent it's 1. If it's not 1, it's not ln. So what are you supposed to do? You simplify. You take 3 to the top, it becomes negative 3. Then now, do you remember this is the first rule. Do you remember the first rule? If I have, did I do it here? I did it on the formula sheet. If I have exponent, what am I supposed to do? Add 1 to the exponent and divide by that answer also, right? So, which means this one, I'm going to leave 10 as it is. I'm going to add 1 to minus 3. I get minus 2. Then divide by minus 2. Then usually in N4 they say leave your answer in positive exponent. We know 10 over minus 2 is minus 5. If we take x minus 2 to the bottom, it becomes x squared. Like that, right? Guys, these rules are very important, because when you do differentiation, integration and differentiation, you get questions like this. They give you all the rules in one equation. You must apply all the rules. You see, that's dy dx, it's differentiation. Let's check integration. It's the same thing. Here's integration. You see, integrate this. Same thing exactly. You understand? Perfect. Okay, let's go back to our formula sheet. Okay, we did the ln, the sine, the cos, the tan. We're not gonna do them here. We did them. I was giving you examples here. I just want to show you one last example. If we check the formula sheet, what is the differentiation of sine 3x? The differentiation of sine 3x, I think I should be using a black color now. I'm no longer on the formula sheet. The differentiation of sine 3x, we know the differentiation of sine, it's cos from the formula sheet. Then, this is what I was telling you. They never show you that multiply by the differentiation of x at the end, because the differentiation here, this number here, is no longer 1x, it's 3x, so you must multiply by that 3. So people who are already know how to do this, they know that they can just write the answer straight as 3 cos 3x, right? For example, if I have cos 2x, the differentiation of cos is negative sine, so this will be negative 2 sine 2x. This 2, it's the differentiation of 2x. You see, then the sign doesn't change. This is like chain rule. This is a rule we will do in differentiation. When we do quotient, product, we will also do chain rules. I'll do one video for product, one video for quotient. There'll be very short videos because it's easy. That's it. Yeah, so other things, so guys, most of the things you just follow the formula sheet. Believe me. Like here, I just saw a question here for, let's check here for 5.3. we are given minus 2 over cot x. You cannot differentiate if it's at the bottom. You must always take it to the top. So when I simplify this, I haven't differentiated, so I still have y this side. Make sure you put that y until you differentiate. Forget about the rest. I will simplify the rest, but forget about it now. Or we can just do this as an example. So this is 2 over cube root, square root of x cube minus 5 over sine. You see, we cannot differentiate sine if it's at the bottom. We cannot differentiate x if it's at the bottom. Then plus 4 minus 3x plus 1 over 7e3x. Another thing which is important, guys, is this thing here. If they say dy dx, it means you are differentiating a function of y respect to x. So anything that doesn't have an x in your formula, you take it as 0, because a differentiation of any constant, any number, let's say k, constant, the differentiation of any number, it's 0, always. Then the integral of any number, if it's respect to dx, the integral of any number will be, you just add x. So if this is 10 integral of 10 dx, the answer will be 10x plus c. Those are two small things you should pay detail to. So if I integrate anything that doesn't have x, the answer will be 0. If I differentiate. If I integrate anything that doesn't have x, you just add x. So for example, they can say integrate y respect to x. Y, it's not an x, it's like a constant, so your answer is yx. Do you see? Okay, let's continue here. So first we have to simplify. What do we have to simplify? We have to take cot to the top, we have to take x to the top, we have to take sine to the top. This is a normal exponent. This is fine, we don't do anything to it. Can we differentiate the exponent at the bottom? No, we must take it to the top. So let's start. Your cot, if it goes to the top, it becomes tan. How? From the formula sheet. Oh, it's not in the formula sheet. You should know them. They are called corratios. It's corratios. Corratios, don't forget. You should know them. It's your sine. It's 1 over cosec. Your cos, it's 1 over sec. Your tan, it's 1 over cot. These are corratios. So this applies to the opposite. Your cosec is also 1 over sine. Your sec is also 1 over cos. Your cot is also 1 over tan, right? So here I have 1 over cot. It becomes tan. You see, the minus 2 is still there. How do I change 2 x exponent? X cube inside the square root is the same as x 3 over 2, right? Remember, square root is 1 over 2. 1 over 2 times 3 is 3 over 2. If I take it to the top now, it becomes negative. What is the coratio of sine? I wrote it for you just now. It's cosec. And guys, pay attention. If this is only x and this is only x, I didn't pay attention, but I can see they are only x's. Sometimes you find out it's 2x. It's 2x. You see, now this one we don't change it. The 7 is just a number, we leave it at the bottom. E, we take it to the top, it's negative. Do you see? Now we can differentiate. What is the differentiation of tan? You go to the formula sheet, it's sec squared. Where is it? Tan here, it's sec squared. Do you see? You go to the formula sheet to get minus 2 sec squared. This is a normal exponent. What do we do with normal exponent? We multiply the 2 with the exponent. 2 times minus 3 over 2. You do it in your calculator, you get minus 3. Then what do we do after? Why am I putting time? After we subtract the exponent, because this is differentiation, right? If I subtract 1 here, I'm getting minus 5 over 2. Then what is the differentiation of cosec? Check here. We check because we are differentiating. We'll go from y to dy dx. It's negative cosec cot. But because I have negative there already, it will be positive cosec cot. What is the differentiation of exponent? Don't forget, first write it as it is. Number 2, lean off your base. Number 3, times negative 3, which is the differentiation of the exponent. But that negative will make this positive. You see? Now the last one. 1 over 7 e exponent negative 3x, guys. This is still an exponent. The only difference is, okay, how do we differentiate the exponent? First, we write it as it is. Number 2, lean off the base. The base, this is the one which has exponent, right? Times what? Negative 3. So I usually don't show negative 3 there. I just show 3. Then change this sign and put it as negative. So guys, okay, we are done. Then plus c. With e, every time we have e, we never show this. Why? Pause the video now and press ln e on your calculator. You notice ln e is equals to 1. So every time we have e, I'm glad I met e because I didn't cover it when I was telling you other things. So remember, the differentiation of exponent, you first write it as it is. With e, you don't show ln e, you just go straight to this one because ln e is 1. The same with integral. If I integrate e3x, first write it as it is. We are supposed to divide by ln e and times 3, so you just say 3. You don't show that ln e at the bottom because this is 1. That's the difference between your e and your normal exponent. If I have 3x and I have ex, if I differentiate this, I'll get 3x ln 3 times 1, right? If I differentiate this, I'll get ex times 1. The ln part is not there because ln e is 1. Guys, I hope this is clear. Next video, we will start with differentiation. I will start from chain rule. After chain rule, we can do product rule and quotient rule. Thank you, guys.